Bismillahirrahmanirrahim. Assalamualaikum and a very good day to you all. In this video, we continue about chapter 11 on selection of ball and cylindrical roller bearings. Okay, this book is taken from the chapter 11 from book Shigley Mechanical Engineering Design, and the pictures in the book in this video is taken randomly from Google Images and also from the book itself. Okay, so in the previous video, we have learned about equivalent load, learned about how to calculate equivalent load, radial load, and thrust load for ball bearing and also for cylindrical ball bearing. So this video will start with example 11.7. If you have the textbook with you, you will see this chapter start with uh, the subchapter start with example. Okay, so example given here is the second shaft on parallel 25 horsepower foundry crane speed reducer contains a helical gear with pitch diameter of 8.8 inch. Helical gear transmit components of force in tangential, radial, and axial direction. Okay, the components of gear force is transmit to the second shaft as shown in figure 11. Okay, so you can read all the question, and the question wants us to find the roller bearing for location D and the ball bearing angular contact for location C, which is we will see in the next slide. Okay, and importantly, the application factor is given as 1.2, the AF application factor. So see here, this is what the question means. This is a picture of a crane reducer I taken from Google Images. You can Google image for crane speed reducer. Uh, some of the tips, if you want to understand what the question means, you should know the picture, have the have some idea the picture of what the question wants. Okay, so this is another picture on the left on the crane reducer. You can see here. You can see here. This is the part. Okay, for the crane hook. This is the part that represent the crane hook here. This is the crane hook. Okay, this is the crane hook represented by this. Okay, so there is a hook going down here. Okay, it it provided direction x, y, and z. If you can represent with x, y, and z direction, this is the hook and this is the crane, the crane cantilever. Okay, the crane cantilever like that, and then this is the whole loading inside, and then this is the point A. This is given as point A, where is point B, and attached directly to the hook, and this is point C, and this is point D. Okay, the question asks what is the selection of the roller bearing for point D, here, meaning that what kind of roller bearing that's suitable for point D. This is the question asked. Okay, let's see the solution. Okay, uh, the torque transmit is T equals to 595, 404 equals to 2404 pounds inch. Okay, speed or rotated horsepower given by this is the speed, 655.4 revolution per minute. Again, in order to do this question, you trace back how the numbers get. Okay, how you get this number, 595, 404. If you understand how to get this number, you will understand this answer. Okay, okay, radial load D is like this. Okay, and you get 319 pound. Radial load at C is 464 pound. Okay, the individual variability if equal must be at least reliability is 0.99. Dimensionless design life of ball bearing above bearing is like this, 393.2. Okay, this is the radial load given for this, radial load given at this point. Okay, and radial load C given at this point. The load, you try to remember what I said about radial load. The radial load is the load that is rotate, caused by rotation. Of course, the bearing, the shaft is connected to the bearing, and the shaft rotate, and then when it rotate, it will give radial load. Okay, so from solution A, you can find from the equation the wheel parameter, for example 11.3. Go back to example 11.3. Okay, go back to the video that shows example 11.3 and application factor of 1.2 given 1.2 and ball bearing is roller bearing is A equal to 10 over 3. At D, the catalog rating should be equal or greater than C10. Okay, meaning that when you go for the catalog, you open the catalog, just like when you go to supermarket, you go to IKEA, you go to Tesco and everything, you have the catalog with you, and this catalog, you choose the catalog that shows the ball bearing is equivalent to 16. Okay, it's equivalent to 16 kilonewton. Okay, not below that, at least 16 kilonewton. Okay, and then from solution in the absence of thrust component makes selection procedure simple. Okay, the what is a thrust component? Like I said, thrust component is loosely said that it's like an axial load, but it's not an axial load. Axial load given a thrust load, like they want to push you and hit you uh, like that. Okay, this is called the thrust load. Okay, no thrust load in the crane. Of course, it's no thrust load in the crane. Thrust load happen the most significant example that is nearest to you is your brake, car brake. Okay, the brake, when you hit the brake component will clamp the wheel of the tire and will make it slower. That clamping force, the moment that it hit the tire, it has the thrust load. Is this is the nearest example that you can imagine for thrust load. Okay, so choose 02 35 series or 03 35 millimeter series cylindrical roller bearing. Taper is from table 11.3. We will see table 11.3 in the next slide. Okay, the ball bearing at C involves thrust component. Selection procedure requires an iterative procedure, meaning that you will do this step. If you get the satisfactory result, it is okay, stop. If not, the result is not satisfactory, you will you will revise your result again and again and again. You do again and again until you get your satisfied result. Uh, this is definition of iterative procedure. Okay, so choose Y2 from table 11.1, choose C10, tentatively identify a suitable bearing. Okay, find FA plus C0, enter table 11. 1, obtain new value, find C10, same bearing is obtained, and stop. If not, go to the next bearing, go for step 4. Okay, meaning that from this table 11.1, okay, you choose the suitable bearing and you put the C10 value. Okay, if not satisfied, go back again, choose again. Okay, let's see table 11.3. This is the table 11.3 for load rating for cylindrical roller bearing. Okay, 0.3, 0.3 series. And you can find the bore diameter and everything. That is the reason that I said when dealing with the bearing come from the company, you cannot choose. You have to design your shaft accordingly to the bearing. This is the C0 rating. Okay, given like uh, in the previous example, you get the answer 16 kilonewton. C0 here 16, and then you get 16. This is 17. Okay, this is 17, meaning that you have to choose this one. Okay, 35, around 35, this one 17, or you may choose 03 series, you may choose this one. Okay, why don't you choose this one? Okay, because it's too over. Why you may choose, but why choose too over spec? Okay, you choose slightly over that value. The value that you get is 16,000. The value that you get is 16k Newton. Okay, the available value from the stable is 20. You choose 20. The available value is 17. You choose 17. Don't choose. Don't have to choose more than that. Okay. This is table 11.1. Equivalent radial load for factors for ball bearing. You divide FA equal to C naught. You get this answer. Your answer may be in between this. Okay. If you get the answer that's satisfied, okay, stop your calculation. Not satisfied, continue the calculation until you get the value that you are satisfied. Okay. And then solution from first examination, approximation, take middle entry for table 11.1. X2 equal to 0.56, Y2 1.62, and you get this value. You put 3.65 kilonewton, and you get with ball bearing A equal to 3, C10, you put this value, and you get this is 365, you put in this equation value, and you get 553.2 kilonewton. Okay, this is again table 11.1. Okay, and then this solution angular contact 0 to 60 bearing has you can read it C10 55, C not 35.5. Step 4 becomes like this, and then you get 0.431, which makes table 11.1 approximately 0.24. You get this equation which is greater than 24. That's what I say. This value is in between. This value is in between. You have to extrapolate. You have to estimate what is the suitable value. Meaning that for your answer, if you are doing the test, doing examination, any answer in between the value is logical and acceptable. Okay. Okay. You can see the value in the table is 0.02, 0.056. Your value that you want is 0.043. It is in between that. Okay, so any answer for Y2 is in within the range is acceptable. Okay, from equation 11.12, Fe equal to 3.97. For calculation for C10 change only F equivalent, so you get 57.9 kilonewton. Okay, this is the table 11.2. Uh, so this is the last slide for it. So for the table 11.2, angular contact bearing is 0.2, and C10 the 63.7, C0 41.5, and you get this. Okay, 0.0369. E approximate 0.23. Now which is greater than 0.23, you again by interpolation you get 1.9. Okay, which again it is an in between value. 0.028 and 0.042, it is in the table. Your answer is in between those two values. So you should interpolate, and whatever answer you give in between the range is acceptable. Okay. So F equivalent is 4.07. The prior calculation change in equivalent, so you get 59.3. So angular contact is still selected, so iteration is complete. Okay. So, so this is how you choose. Whether you choose 0.2 series or 0.3 series, you have option 0.2 and 0.3 series. In the end, you select 0.2 series because of this answer is the nearest to you, 99.3 kilonewton. So go back, just take a while to do this question again. If you have the textbook with you, it's better. Trace back the answer, trace back the number. Okay, trace back the number so that you will understand how this number come. Okay, and then you will understand why the reason given here. Okay, that's all for this video. We will see you in the next video on selection of tapered roller bearings. Thank you very much.